Electric traction system. Basically, it is an important part of utilization of electric power. And the fact is that how we can utilize that electric power in different fields that has been illustrated in this syllabus. And among the total syllabus, the most important portion is utilization of electrical power in case of traction system. That means Wheeler traction system. So first we will basically traction system. Act of drawing or state of drawing propulsion of vehicle is called traction. Or we can say that the locomotion in which the driving force is obtained from electrical motor is called electric traction system. There are various electric traction systems like electric train, trolley, buses, diesel electric vehicles, gas turbine, etc. And not only this, electric traction includes battery electric drive, freight electric drives also. This system of traction may be classified broadly into two groups, namely 1. The traction systems which do not involve the use of electricity at any stage and called the non-electric traction system, such as steam engine drive or internal combustion engine drive, etc. And another part we can say that traction system which involves the use of electricity at some stage or the other are called electric traction systems. As for example, we can say that diesel electric drive, freight electric drive, etc. Now the system of electric traction may be further classified into different groups, like the group consists of vehicles which receive electric power from distribution network and fed at suitable points from either central power station, or the second group consisting of self-contained locomotives such as diesel engine trains, ships, petrol, electric trucks, lorries, battery-driven roads, etc. Now in traction system, the major classification we can divide, that is non-electric traction and electric traction, which I have already mentioned. That the non-electric traction includes steam engine drives, internal combustion engine drive, that is IC engine drive, and electric combustion or traction includes diesel electric drive or gas turbine drive. In that way, we can majorly divide the electric traction into different areas. Now, the system of electric traction that can be also divided. How that electric traction of systems can be considered. So, there are mainly major two groups, like the group which consists of vehicles which receive electric power from distributing network, fed at suitable points from either central power station or substations, and this group can also subdivide like system operated with DC such as trolley, buses, tramways, railways, or system operated with ACs like railways. And another group consists of self-contained locomotives such as diesel electric trains, petrol electric trucks, battery-driven road vehicles, etc. That means our traction system is basically divided into different areas or regions. In this chapter, we will mainly highlight on a portion of electric traction part. So, for highlighting that one, I have pointed out some major requirements of ideal traction systems. That is, the starting tractive effort should be high so to have rapid acceleration. Second, the wear on track should be minimum. The equipment should be capable of withstanding large temporary loads. Speed control should be easy, it is pollution free, low initial and maintenance costs, and locomotive should content and able to run on any route. That means electric traction system or any kind of traction system has these major advantages. For these major advantages, our electric traction system became very much popular. And these are the basically some merits of electric traction system. These merits are included in case of electric traction system. It's not for non-electric traction systems. It has high starting torque, less maintenance, cheapest method, rapid acceleration and braking, less vibration, free from smokes and fuel gases, used for underground or tubular railways. That means the railway systems, we can see from our experience, we can understand that railway systems is very popular. It is very much population free, pollution free. It has less vibration, good starting torque. All these points they are maintaining, but it has some demerits also, and those demerits are like high capital cost. Definitely when we are building a total traction system or railway system, it involves lots of equipments, lots of components required, high voltage transmission lines, substations, railway track, engines, everything is very costly. So that means initial costing is very high. Second one is problem of supply failure. That means electric traction is totally based on the supply, electric supply, and if the supply is failed, that means the total huge system will be collapsed. That is a major drawback. And thirdly, the electrically operated vehicle have to move on guided track only. That means the fixed track it has, we can see it, and we cannot move our traction drives in different ways. Not like that. We can move our drive in a fixed track. Fixed railway path is there, and our railway engine can move on that track only. Okay. Additional equipment is required for achieving the electric braking and control. Definitely, electric braking is a very huge portion, and it is definitely very essential for moving traction, electrical drive, and that control of electrical braking and control is very important for any kind of traction system. Now this electric supply system, so for traction, it can be divided into three major portions of supply. That means the traction system run by DC system. A portion of electric traction required DC supply only. That means, for example, I can see for running the DC series motor or the battery supplies, all these things are DC. And there is another portion which requires AC supply of single phase or three phase supply. Second, it is composite system. That means where AC and DC or single phase and three phase both are interlinked. That means single phase AC to DC or single phase AC to three phase AC. Like this kind of conversion is also there. Now, in the total traction system, the very important part, which is speed time curve. Actually, speed time curve is basically indicating a graph which covers the total portion of a railway traction system. When a system is moving, a train is moving, then we can see that how it is going on. The movement of trains and their energy consumption can be the most conveniently studied by means of speed time and speed distance curve, which show respectively the speed at different time instants after the start run and the speed at different distances from starting point. The curve, in short, we can define it like that way. Suppose we are taking x-axis and y-axis. X-axis basically define the speed in kilometer. Speed in kilometer per hour, and y-axis defines the time in second. The time in second. So suppose for a duration our speed curve, time curve is like this. That means the curve drawn here between speed and time, taking speed in kilometer per hour, and y-axis defines the time in second. The speed time curve provides complete information of the motion of the train. This curve gives the speed at various time instant after the start of run directly. The slope of the curve at different time gives the acceleration at corresponding instant or speed. Suppose this portion, it indicates the speed of running curve. That means up to this time the train is moving with increasing speed. That means train is achieving the speed. This part, from this to this portion, basically this is free running zone, where the train is moving with a constant speed, and here this part is basically coasting, and after that it is braking. So the coasting part means in this point, after free running period, the power supply is cut off and the train is allowed to run under its own momentum. The speed of train starts decreasing on account of resistance of motion of the train. The rate of decrease of speed during the coasting time is known as coasting retardation. That means this part is basically coasting time, and after that train brakes and it will stop. So basically using this speed time curve, we can understand that the total train movement throughout the time from starting to braking part. And this is the basic introduction of electric traction. In my further classes or future classes, we will let us understand how these things are going on, and how the electric traction and speed time curve. From speed time curve we will understand different numerical problems. Those we will highlight in our next lectures. Thank you. So in that way we can define the speed time curve of the train movement, and the total duration of the speed time curve is divided into three portions. One is for running part, one is for free running part, and third one is coastal period, and fourth one is for braking period. That is the total speed time curve showing that how the train movement is going on. And this is the brief description which I have already told you, and in future we will do all the details. And from the speed time curves, and there are various numerical problems comes related to this, where the timings are different, and speed timing and free running timing or coastal or braking, everything is moving and that part has been changed. So in this way we will go further and proceed in this matter, and it is very good that you have listened my lecture, and thank you all.